So this is a continuation of the voiceover by Ramneet Kaur for AP Calculus BC for Chapter 9A. This is 9.2, which is series. So difference between a sequence and a series is that a sequence is a collection of numbers. For example, a of 1, comma, a of 2, comma, a of 3, and so on and so forth, which could be finite and infinite. A series, on the other hand, is a sum of sequences. So it could be also represented as the sum of n equals 1, which is the start, and the end would be infinity of a of n. This could be known as the terms of a of 1 plus a of 2 plus a of 3 plus continued. These numbers either could be finite or infinite. When they're finite, they usually equal and have a sum that you could calculate. But when they're infinite, you're not sure, so they could maybe have a sum or maybe not. This is an equation for the sum. It's the sum as n equals 1, which is the start, going to the n number of terms of a of n, which equals the s of n, the sum of the terms to n. An example of this would be the sum as n equals 1 going to the 5 terms of 2n. So when plugging this in, you would start off by plugging in 1. So 2 times 1 is 2, which is the first term. The second term you would add on would be 2 times 2, which is 4. 3 times 2, 6. 4 times 2, 8. 5 times 2, 10. And since that's the fifth term, you have to stop there. Add them all up together, 2 plus 4 plus 6 plus 8 plus 10, which would equal 30, and that is your sum to the fifth term. To see if this diverges or converges, you would set up the equation, for example, sum as n equals 1 to infinity of n. The first step would be you would set up partial sum, which would be s of n equals, when you plug in n, 1, 2, and 3 for n, it'd be 1 plus 2 plus 3 plus 4, all the way until you're adding n. For the second step, you would find the formula of s of n. So when you figure this out, you would use the s of n terms that you found out in the first step of partial sums. And then you could see that this would be n times n plus 1 all over 2. For example, when you plug in 1 into it, it'd be 1 times 1 plus 1, which would be 2 over 2, which would all equal 1 in the end, giving you your first term. And then the third step would be limit of n approaching infinity. And so when you set this up, it would be limit as n approaches infinity